Look at assignment 9.1, number 3, part B. I just asked the question, what heats up the air? And Dan just gave us the correct answer, which is the surface or the ground. So this is the ground. Sunlight's coming in. And that makes the ground get hot. So sunlight heats the ground. And the ground heats the air. So the farther you get away from the air, the farther you get away from the ground, the colder it's going to be. That's, and what Omar said, that as molecules go up, does pressure increase or decrease?
Pressure decreases.
So the molecules are farther or closer?
Farther.
Right. And in the process of them moving away from each other, they actually cool down. To help you understand that, I do a demonstration in physics. Those of you who have any physics might possibly remember it. They'll actually remember it. I had a cylinder with some gas in it, and I pushed down hard enough on the gas, so I compressed it so quickly that the gas got hot enough to make something catch on fire inside. Remember what it was that caught on fire? Yeah, that's right, little pieces of cotton. So when you compress gas, you make it hotter. When gas is allowed to decompress, it gets colder. And as air rises, it decompresses to become lower pressure, and it cools down in that process. That's important for a minute when we talk about the rain shadow effect. Okay, so there's one topic we should bring into this right here. And this was not listed on your study guide, but it's called the heat island effect. What is a heat island? Heat island effect. So, heat island. LA is considered a heat island. But, what's that? To some small degree, you can say that there are more people and they're therefore giving off more energy. But that's a very, very, very small effect. Thanks. But the main, Jose?
Isn't heat dropping in a certain area due to various geological reasons?
Geological reasons?
Like in the valley, heat drops in
Yeah, what you're describing is legit. We call that microclimates. And I experience that every day when I ride my bike down Old San Marcos Road, which is one of those really super windy curves. When I get to crossing over the Maria Ignacio Creek at the bottom, it is easily 10 degrees colder than it was a quarter of a mile up. Because there's this microclimate. The cold air does sink into that little valley. And this morning actually, you go through it and it takes your breath away sometimes. Like literally, I start like gasping for breath because it's so cold. What you described as microclimate, and yes, that does come into effect. What we refer to the heat island effect though is this. Cities are hotter than neighboring regions. So the cities act like a heat island. Why would that be?
pollution.
What kind of pollution?
Air pollution.
You have to be more specific.
Carbon emissions.
That's usually not considered to be one of the main reasons.
Smog.
Even smog is not necessarily considered to be, it's more the opposite. It's the heat that helps to produce the smog, rather than the smog producing the heat. Well, what are cities? When you're walking around cities, what are you mostly walking on?
Concrete.
When you're driving in cities, what are you driving on? Yeah, so we could say, especially blacktop. Most roads are blacktop because it's cheaper than concrete. So, blacktop versus, what would it be otherwise?
Grass.
Yeah, dirt, grass. And blacktop heats up a lot more, going back to what Dan was saying. Sunlight coming in heats up the blacktop. That blacktop does a much better job of heating the air above it. That's one reason. And you also end up usually having a lot less shade because you have fewer trees. What do trees do to keep an area cooler? You know, CO2 doesn't have a big, I mean, CO2 is a greenhouse gas, but that's in the stratosphere or even higher. don't really see that effect from right around us. But trees have an effect of, they monitor, or they can affect the temperature in what way? Shade, yes. Greg? Is that you?
Yeah, shade.
Right. Fewer trees, less shade. You know, trees are very good. When sunlight hits a leaf, the leaf gets a little bit warmer, but it's using a lot of energy to do photosynthesis. But when that sunlight, there's no leaf there, and that sunlight goes all the way to the blacktop, that blacktop definitely gets hot. Okay, so you have less shade. Let's add one more to this. The fact that you have more or less runoff occurring in paved areas. So when you have more runoff, you get less water standing around, meaning less evaporating water. And I gave you the answer, I should have asked it. Less evaporating water. What's the deal with the evaporation? Does evaporation make things warmer or cooler? Right, that's where our bodies do it. Yeah. So if you had like a swale area, which we haven't talked about swales much, but sometimes swales are built. It's kind of like an area where water runoff can come and then spread out and sit. It's like creating a natural place for water to pool. Kind of like a wetland. And that from there can sink into the ground or it can evaporate. As it's evaporating, it definitely contributes to cooler air. Okay, so this is the heat island effect. And I just kind of want to put it in there because it's the best place for it to fit into our discussion of environmental science. It is one of the topics of APES. Okay. Now, let's go to another question here. Number 4. Any questions about heat island effect and this sort of thing? What can you do then to, like...
Are there any, like, heat islands that are not, like a city kind of thing? Like an example of a heat island that's not, like, just because of the big population of people in one place?
Yeah, Lily mentioned about that, just having a lot of people, does that make a heat island effect? I mean, if you're in an enclosed area, for sure. Like the auditorium, case in point, it gets really hot in there sometimes. But when you're outside in nature, the heat that we produce is so insignificant compared to sunlight energy. Yeah, and of course, just if you have an area soil that's been desertified, it's not going to have the same amount of vegetation. So it's going to start to become more of a heat island, as opposed to planting plants that can help control the temperature. Okay, let's go to thanks for the question. Anything else? Okay, question number 4. We're building on some concepts here. And number 4, oh yeah, the big question here.
I know.
Okay, you got this one, Carly?
Did you know that 90% of Harvard grads get this wrong? It's a statistic.
Did you really find 90%?
Yeah.
Because I kind of guessed, and that's what I said this morning to my first period of class.
Yeah. Because actually, everyone thinks that summer's hotter because the Earth is closer to the sun, but it's actually hotter because the Earth's axis is tilted.
Yeah.
Okay, so is anybody wearing yellow today? I was hoping for there to be somebody with a yellow shirt that could be this. Okay. You know what, Adrian, would you mind standing up for a moment? Okay. All right, you're going to don my vest. He is now the sun. And the cool thing about this is if you get close, you can actually see it reflecting in your skin. Since it is reflecting yellow light, that's why it's yellow. Okay, Carly, come over here and show us how the Earth would be oriented during solstice day. Come on up.
But I don't really know.
You wanna hand it off to somebody else?
Yeah, I'm not gonna be able to do it right. Does anyone know?
Tag team? Phone a friend?
Dan might know it. He might be part of this.
Oh yeah, Dan. You're gonna pass this test.
Yeah. You're not gonna be that 90%, Dan.
Oh, ready? Gonna break the odds. you are going to show us the correct orientation of the planet on the first day of summer, summer solstice.
First day of summer.
Don't get too close to the sun, you might burn up. Yeah, that's better. Okay. Is he right? The globe is meant to be held with the base level. Okay. Is he correct?
Well, then I meant to do it this way.
Is he correct?
No, it's the other way around.
Yeah, you were right the first time.
Well, yeah.
Okay. If you look at right here, we have North America. So here's us, right? And when you held it that way, North America continent is tilted toward the sun. So on that day, June 21st, almost exactly 2 months from today, I'll be partying it up at solstice celebration. And then I'm going to look above me, and the sun is going to be the highest that it will ever be in the sky. I wish I could say that it'll be directly overhead, because that'd be pretty cool. But do you guys know this line called the Tropic of what? Tropic of Cancer, right? That is the most north you can be and still have the sun directly above your head. And we are just a little bit above north of the Tropic of Cancer. Okay, so Dan, take us to 6 months later. So the Earth doesn't move around the sun?
Well, yeah, I figured.
No, wait, does the sun move?
Yeah.
No.
Okay, we don't go quite that far, but we do rotate a more or less circular path, elliptical. Okay, so he has not changed the tilt of the Earth, right? Because that's a constant. It's just the moving. It's spinning, right? But notice that this orientation never changes. It's not like the Earth does this for its axis. No. So now, who is experiencing summer? Right, South America, and for us it's winter in North America. Every day, you know, we get the night and the day effect, but it has to do with the angle of those rays coming in. So, what questions, or how well do you understand this?
Show us what it looks like during the fall.
Okay, equinox. So Dan, rotate, you can go behind him. Rotate in orbits until you get to equinox. Okay, so is the Earth still in the correct tilt position? He hasn't moved it? Okay, that's good. Notice which way it's tilting now. Toward or away from the sun?
Was Adrian's?
Neither, right? Perpendicular. Sun, and it's tilted this way.
What about the moon?
This is a really pretty amazing thing, because this is the only day of the year that everybody anywhere on the planet can see the sun, or will experience equal day, equal night. That's what I should say. Exactly everybody on the sun, because nobody on the sun is more or less tilted than anybody else toward the sun.
You mean nobody on the Earth?
I mean, no place on the Earth is more or less tilted than any other place, because nobody is not tilted toward, is not tilted away.
Then this is the fall.
Well, it's hard to say. Is that the fall? Depends which way does this Earth actually go? Clockwise or counterclockwise?
Isn't it?
I'm pretty sure it goes clockwise.
You like it?
So that means where you are, you'd be going there next. So then you'd be becoming summer. So you must be which equinox?
I must be spring.
Right.
Damn.
Bam!
Okay.
Nice job, man.
Any other questions? That was a good point there, Greg. Okay, so I'm going to ask you one final thing. Can you walk to where we are right now? Because when did equinox happen?
We're about here.
No, because that would be March 21st, which is equinox day.
About here.
Yep, nice. 1/3 of the way towards summer. All right, let's give Dan and Adrian a hand. Thank you. So, if you were actually living on the North Pole on in the dead of winter solstice, you would be right here. And imagine where Adrian was standing right there. Can you see how this part right here would be in the shadow of the Earth? Would you be able to see the sun?